Good afternoon, everyone. And hope you are enjoying the great day. So today's session, what I will be covering is how you can leverage Tekton Pipelines to create your own workflows and automate it. So has anybody here already worked with Tektons? Anyone? Tektons, Jenkins? Lots of Jenkins, GitOps or any other workflow management tools. Yeah. So today we will be discussing about Tekton. It's an open source tool available. So as my name is Sudhish and I work as senior software maintenance engineer, and one of the major questions I always receive when I tell someone that I am working as me is that what exactly does software maintenance engineer do? So Red Hat, those of you who know about Red Hat, they ship lots of product, most of them based on open source. And we have a lots of team who supports, develops, supports and provide all necessary support for those products to enabling that customers. And we have a team of support engineers as well, and there would be situations where customers would be having issues with developing the architect, designing them, and even situations where their production has been completely broken down and they don't know what to do. And their entire infrastructure is set up based on Red Hat product. So basically, I or my team basically comes up in those situations, helping them to resolve those situations or designing better architectures and everything. That's something about me. So before starting, is there anyone over here who doesn't know what a workflow, CI/CD workflow is? Since it's a DevOps, I think almost everyone would be aware of that. This is the most basic pillar of any DevOps, and any person over here, if you have attended any interview or anything, this should be one of the questions which was asked directly or indirectly to you. So basically, CI/CD workflow is, in basic terms, it would be something like creating a product code and product from scratch, then ship it to the production and make it available for your customers. The complete workflow in between there, it can be created into a pipeline and we can design it as a workflow and deploy it. So this is just an example where a user checks in the code to Git repo and then it's built. We have automated tests running on it, and everything is successful, then we deploy it to a cluster which has multiple containers across the world maybe. And then what's Tekton? So everyone, I think many people here has already worked with Jenkins. Tekton is a tool which is similar to Jenkins, but it's basically an open source Knative tool which is developed to provide CI/CD solutions. So Tekton can be applied or created as any Kubernetes resources which is already available in your system. If you are working in a cloud Knative environment and you don't want to go outside Knative environment to build your own workflows, you want to create it using the same resources, using some custom resources which is available for Kubernetes, then Tekton is a way to go. So similar to any CI/CD workflow tool which we are having, Tekton also has few building blocks. The most basic unit of any Tekton workflow would be a step. So in Tekton world, a step can be anything which you can execute as a script or command. So anything that you can think, you can in your command line or a scripting tool, if you can execute it, then that can be converted into a step in Tekton. And in Kubernetes environment, every step would be run as a container. So every step would be having a container and it would be run separately. And the next unit would be task. A task is a group of steps which is grouped together because of their functionality, similarity or dependency on the resources or anything. So a task is managed by a pod in Kubernetes environment which can have multiple steps or a single step which is executed as containers. And there can be a sequence of tasks which is executed one after another or maybe parallelly And so this entire workflow of tasks, which includes steps, is executed as a pipeline in Tekton. So these are the three basic building blocks for this Tekton tool. So this is how the task YAML look like. So it's nothing different than any of your Kubernetes resources you have ever worked with. It's the of-kind task, and it would be having three main elements. Obviously, the most major one is the script, where your actual execution commands goes in, what you need to execute it. Then an image. So in Kubernetes environment, it's spun up as a container. So you need an image on the basis of which the container can run. And the third would be the name of that task. In the right hand side, if you see the YAML, that's the actual implementation object of that task. So task is the template, how the steps should be executed and what needs to be executed. But actual implementation object, you may have to pass the parameters to that task and execute it. So task run is the custom resource which enables you to do that. And similarly, we have something called as pipeline and pipeline run. So if you see pipeline, we have multiple tasks reference to it. So you can either directly embed the complete task code inside this, or as I have shown here, you create a task separately, apply it, then just refer it over here. So here we will be providing the params and everything, and also one more parameter is run after, which defines the sequence. So you don't have to explicitly code or write this YAML in the order which it needs to be executed. The run after basically ensures that after which task this is to be executed, and there can be multiple tasks which is executed after a single task, or you can wait for multiple tasks to complete for a next task to begin. So you can customize it as it required. And similar to task run, pipeline run is the execution object for the pipeline. So basically in this talk, as I told you, we will be mostly concerned about how we can leverage using Tekton to automate your workflow. So basically working with lots of products and lots of customers, one thing I always learned about is that the number of manual intervention, if you reduce the number of manual interventions in your infrastructure code or system, that reduces the number of mistakes or number of failures in your system. Does everyone agree with that? The productivity, it will reduce the downtime of your system to a great amount. So recently I had a situation where one of my friends faced an issue where they were having an application deployed in their system, and it was calling some remote service. And interestingly, they had two versions of remote service. One only had read permissions and another one had read-write permissions. So due to some issues, whenever there is some load management, some other issue was that remote service, they were changing switching all those services. So they were making the read-only service as read-write and write-only service as read service. So we had an application deployed here which was connecting to that service using the endpoint. They were not changing those endpoints in the application, but they were thinking that they thought it would be a smart way to do is that in the DNS configuration, they just switched the IP address of the both services and kept the endpoint safe. So what the issue happened there was that when the application was running fine, there was no issues, but some transaction when it was writing, it was throwing error that there is no write permission. And we debugged, the issue came out like it was like the connection details were stored in the session and session was on, and the session details didn't got refreshed or cleared when the IP address which happened at the back end. So this friend, we had a discussion with us, what can we do? So most simple solution would be that whenever you change that IP address, go and clear all the sessions to ensure that none of the old sessions are still active. So he said that there are hundreds of applications deployed over around 500 or 600 clusters, and to clearing, manually do clearing that, it doesn't make sense. So that's where we suggested about why don't you create a, it's basically command to clear the session, and you can always automate it and create a workflow for that. Just create a task for that and implement it. But still they were concerned, even if you create a task, I have to execute the task run. So basically the service is in some North America where the service whichever happens during the lunch time of the time zone, and the engineer over here who manages the DevOps admin is sleeping tight at night, and he gets a call that we switched over the service, you need to clear all the cache, otherwise your customers will start facing issue. That's not reliable solution. And otherwise we have to ensure that there is an engineer working 24/7 just to do this, execute this task run. So basically that's where we came up with a solution where these workflows are executed on the basis of events. So there's a component, there are multiple components in Tektons. So one component that is specifically useful to make the workflow event-driven is something called as Tekton triggers. So what exactly is a Tekton trigger here? So Tekton trigger mainly has few components. The major one is an event listener. So it's a pod which will be running in your Kubernetes environment and listening to all the events happening in your world. So it's basically like a neighborhood. It's basically like a neighborhood auntie that you have, who is always as her eyes and ear open listening to what's happening at your home. So event listener is something which does that part continuously, and it listens to any events which is happening. And the next one would be a cluster interceptor, which is basically, if you have watched Star Trek movies, there is something called as universal translator. When they explore different planets and they want to understand those languages, you need a translator. So basically interceptor here does something similar to that. It basically understand which type of events it's been occurring and understand that payload to exactly know that whether it's a GitHub event, GitLab event, pull request or code commit, whatever it may be. So it can understand all the configured events which happens in the Kubernetes environment. So once this event happens, as the neighborhood handy does, it will trigger and go to your parents basically or family. So basically trigger also does the same thing. It will go to that whatever that is configured inside your trigger template, and it will execute those things. So you can trigger based on any kind of environment, events, where in this case what we suggested was that whenever this IP address is changed, the event is emitted where you just capture those events, and it can be captured on the port which the service is monitoring, and we just want to trigger the task which needs to be executed when event is triggered. So this is a small demo of the triggers application. I have the demo pre-recorded, but I will just attempt to run it live. So the font size is visible for everyone. Or should I basic example of trigger? We have few YAML files over here. The major one would be the Git event listener interceptor. So I will just show you what the trigger consists of. So basically this consists of three major resources. First one is the event listener. As I told you, this is the auntie that you have who listens to everything which is happening in your home. And it's configured to listen to a specific interceptor. And in this case, it's a pull request and of type open, synchronized or recovered. And we have a binding and template. So template provides what it needs to do when the event happens, and binding provides the parameter to that particular template. So this is the binding which just provides the parameters to the template at execution time. And the third one will be the template. So in this template, I am just executing a task run which just prints the revision of the PR and the repo URL to which the PR has been opened. So I have already applied this in my environment, so it's already unchanged most of the things only. So once this is running, you will see that there is a pod coming up with for the event listener. The event should be appended with something called as EL. So this is the pod name, which is up and running. So this event listener pod keeps on listening to everything which is happening in your Kubernetes world. And it also has a service. So in order to access that service, I'm just exposing it on made-threads report, and once it's exposed, I need to trigger that event. So I created a GitHub API which could directly open a PR request on my behalf. So I want to open that PR request. It's 202 accepted. So basically PR has been opened. So we need to check. So event listener has listened to the event. So what does they do? So basically we will be having the task runs getting executed. Once the event has been listened, the task run is triggered, so the template, trigger template has been triggered, then what actually the task run do? What exactly the task run does is that it just prints the revision and the repo URL. So execution may take some time depending upon how big your image is there. It needs to download that image, and if you execute it, so it may take some time depending upon that. So that's how the trigger happens. And I just had one more leverage tool which you could have used. It's similar to the triggers but for developers. So even if you have to create a trigger, you need a DevOps admin who can write that YAML file and check it. But there are many developers who comes. I am the one who developing the code, I am committing it, and I need to wait for a DevOps to create a change request and deploy it in their environment before I test it. So you don't have to do it if you have creating the pipeline as a code. So now everything, even infrastructure is being supplied as a code using GitOps, and similarly Tekton helps you to supply pipeline as a code, where you just have to write the configurations inside your code in a directory called .tekton. You can configure your pipeline runs and all the validation. So the controller here, whenever it receives that event, it will validate the payload which is present, read that directory, creates the pipeline based on that, and executes it. So there is a watcher who continuously observes the status of this particular execution and provides the result to that. This requires two custom resources. One would be the repository on the basis where the code is committed, and the actual pipeline run which needs to be executed. So these are the two custom resources which needs to access. So this is how the pipeline run basically looks inside your code, and if you see the spec part is completely same, only annotation is different. So that's what enables and makes the pipeline into something which can be directly executed from the code itself. It's driven by annotations. So as you have heard, someone said that give me a liver and a fulcrum, I can move the world. So basically DevOps and DevOps environment tools, CI/CD tools are one of that lever which you can use to automate any of the workflow that you have. You can just use it to, in many industries and clients I know that they only use it just for code deployment for software lifecycle purpose. But that's not where you just can use it. Anything, everything which you can be manually executed using your command line, or you can create a script for that, you should create workflow and try to automate that. Hope that you will try it out in your environment. So let me know if you have any questions. So these are a few references. document. I think when the slide is shared, you can refer